While trying to analyze time series data, it is not advisable to directly start with model selection and training. Firstly, we should work with the data and understand it. A good understanding of data helps us in selecting and developing a good model. In this video, we'll be exploring the stationarity of data, its definition, significance, and identification techniques. So, what exactly is stationarity? Stationarity in time series data implies that key statistical properties remain constant over time. Data is stationary if statistical properties of the data, mean, variance, standard deviation, etc., are constant over time in the time series. Also, there should be absence of seasonality, that is, no periodic fluctuations in the long term in the data. Seasonality refers to the presence of recurring and predictable patterns or variations that occur at specific intervals in the long term. Discussing the examples later in the video will help you get a clear idea about seasonality. Now let us take a look at why stationarity of data is so important. The inference drawn from non-stationary data will not be reliable because its statistical properties will change with time. Statistical properties of data are of special interest in time series analysis and predictions. Stationarity simplifies the process of creating accurate models and forecasts. Stationary data is easier to analyze and does not give erroneous or misleading results like non-stationary data. Many statistical models like AR, which is the autoregressive, and MA, moving average, assume stationarity for valid results. Next, we look at how to identify stationarity. Here are some techniques to identify stationary data. First is visual inspection. Visual inspection involves examination of data plots for trends and seasonal patterns. Stationary data should show no obvious trends over time. Next is summary statistics. It requires calculation of mean and variance for different segments of data. Stationary data should exhibit roughly constant mean and variance. Now, we take a look at some examples to get a hold of how to identify stationarity. The following plot represents stock price of a company for 200 days. We would like to know if the data is stationary or not. We can observe that along the intervals, there is no observable trend or pattern. The mean is also approximately constant, represented by the blue line. The variance of the data around the mean appears to be fairly constant. Hence, we can say that the data is stationary. As you can see that there exists a very high value in the data, highlighted in red, but such outliers have little effect on the stationarity of data. Next is the data for Australian quarterly electricity production. If we analyze two subsections of the data, highlighted in red and blue, we observe that they have different means. So this data is clearly non-stationary. Next is the data for Google stock price. If we analyze the two subsections of the data highlighted in red and blue, we observe that they have different means. So this data is clearly non-stationary. The following data represents monthly Australian beer production. We can observe that there is a trend of three peaks in conjunction highlighted in red that gets repeated. Hence, we can conclude that there is seasonality in the data. Hence, this data is not stationary. The following data represents the sales of new one-family houses in USA. We can see that the mean is the same throughout the data plot and the variance is also roughly constant. There is also no observed seasonality. Hence, it should be stationary, right? But it is not. This data, in fact, is non-stationary. The following data represents the number of links captured in Canada. We observe that there is a pattern of one high peak followed by three another peaks appearing in conjunction, which is highlighted in red. So we observe that there is seasonality in the data and it should be non-stationary. But this data is actually stationary. The techniques discussed previously, namely the visual inspection and summary statistics techniques, are somewhat subjective in nature. Statistical methods help in getting a clear idea about the stationarity of data. Let us discuss some statistical methods to identify stationarity of data. First is the augmented Dickey-Fuller test or the ADF test. The augmented Dickey-Fuller or ADF test is a statistical test used to determine whether a time series data is stationary or non-stationary. In the ADF test, there is a hypothesis testing involved with a null and alternate hypothesis, and as a result, a test statistic is computed and p-values get reported. If the p-value is less than the significance value of 0.05, then we reject the null hypothesis and take the time series as stationary. Else, it is non-stationary. Next is the Kwiatkowski, Phillips, Schmidt, and Shin or KPSS test. The KPSS test is another statistical test used for assessing stationarity in time series data. However, it focuses on a slightly different aspect of stationarity compared to the ADF test. This test also reports a p-value. In this video, we looked at what stationarity of data is, why is it important, and some methods to identify stationary and non-stationary data. In the next video, we'll look at autoregressive or the AR models and their significance in time series analysis.